Hello. Perfect. Hi, everybody. How you doing? Thank you very much for coming along. Seems like everyone kind of came along, which is quite cool. So a little bit about who I am and what we're about. So first and foremost, I'm not Ken. Ken unfortunately couldn't make it, so I've come along and we'll duly deliver hopefully something you'll really enjoy. But we're pen test partners, and we do lots of typical pen testing. But obviously, I'm sure you've heard of the research we do. I think last year I was here, I was talking about the Mitsubishi Outlander, and then also started talking a little bit about the ransomware on the thermostat. But this year it's a little bit different. This year I'm going to kind of talk a little bit about DVRs and how we did quite a lot of work looking at DVRs. We bought loads and loads of them, primarily just to kind of understand whether or not Mirai missed anything. And actually there's some really cool things that we found out of it, and actually some quite scary things as well. But then also, you probably saw our article, kind of crashed our website, talking about a dildo. And so we'll cover that one a little bit later on. But anyway, I do kind of have to give a little bit of a warning, because we are talking about dildos and voyeuristic DVRs. So yeah, bear that in mind. But before we do any of that, I think it's kind of quite helpful, I guess, to kind of go over a little bit of a primer as to what IoT is. It's kind of this abstract thing that everyone knows about it, but no one kind of knows what it is in detail, really. But I guess for our purposes, it's a network of connected devices that are not necessarily a general purpose computer. But one thing that's really interesting is it doesn't need to be internet connected for it to be IoT. It also doesn't even need to be smart. It can be a very dumb device. And it certainly doesn't need to rely on any cloud-based service for it to work effectively. But one thing that is very clear, though, IoT is really, really different. This is an IoT car park payment terminal. We were asked to pen test this organization, and we were asked to look at this device. And what this device had is, it was a standard payment terminal, but it had a GSM, or I think it's 3G actually, it used network connection to the internet so it could do the card processing. And it was in a public place, but someone hadn't kind of appreciated that these public devices would live in a public place. And so there's just an RJ45 network connector straight into the back of it, which was directly onto the corporate LAN. And so it took us seconds to own the corporate network from that terminal. The other thing is that IoT has very little user feedback. This is obviously a Philips Hue bridge. Has anyone got Philips Hue? I have. It's really cool. I spent what did I spend? I spent about £120 on all of these lights for my house. And then my wife was just like, it's really annoying using the app. Can't I have a switch? So I spent another £20 on a Philips dimmer switch. So now what I've done is I've spent £120 to turn my lights on and off with a switch. It's a bit dumb, really, right? But anyway, this device, this is obviously the bridge, and the bridge has got nothing on it. It's just got one button and 3 lights. Everything is done from the mobile app. So there's nothing really for end users to interact with. The other thing with IoT is that, it's not just us technology folks who are using it. It's also now non-technical people. The users are typically very much non-technical people. But then you get into the realms of the installers. And when you think about things like the Nest and the Hive, for example, those are being installed by people from traditional trades, electricians, plumbers, gas engineers. They're not technologists. They aren't going to understand it. And in a lot of cases, they don't even come with the tools to check that the device works. Literally all they do is they plug it in and expect it to work. So they have no ability to test that something bad has happened on that device. But one thing is absolutely certain with IoT is that it is incredibly complex. IoT, we've kind of got this naive view of what IoT is. You've got this one device, this single device, and it just connects directly to the internet. And so if you want to compromise it as an attacker, you've kind of got 2 places you need to compromise. You've got the device itself, and then the cloud-based service. The reality is that is not actually what the case is. The realistic view is, yes, you've still got your device, and yes, you've still got your cloud-based server, But then you've got users of the device. Then you've got your network segments, because, let's be honest, the internet is not a direct point-to-point communication. There are network segments in place, and there's firewalls and network devices in place of there. And so there's more things that are going into this. Then, of course, we've got other things on the network as well that are on the same network as this IoT device. We've then got cloud-based users who are connecting directly to the cloud, so from the internet directly to this cloud service, and then using that cloud service to control the device. Then we've got administrators of your cloud network, or perhaps network services on the network, so the routers and the switches along the way. And so you can see there's lots and lots of complicated systems, and not only that, there's backup services, and the administrators of the owner of the company. So let's say you've bought a cloud-connected device. Not only is there the administrators of the vendor of that device, but there's also the Amazon Web Services administrators. Loads of different people. So as an attacker, you can target lots of different places. You can target inside the network any of the devices inside. You can target any cloud-based networks. You can target the IoT user from the internet with a man-in-the-middle position. And then perhaps you could target the actual administrators of the network. You could also look to potentially target the administrators of the vendor of the product. And then also, let's not forget, we've got nation states who've got control over our networks. And so, those switches and the ISPs in between all of these different systems can also intercept the traffic. So when you start to think about that, you've got a lot of really, really complex systems and a lot of complex areas that you can actually look at in this seemingly simplistic system that is IoT. Which makes it great from our perspective, because quite often you'll find that devices are still really, really stupid. And so I thought what I'd do is I'd talk to you about how Mirai has missed its mark, in my opinion. There's a lot of things that Mirai talked about, and it was pretty rubbish, but it missed out on a lot of really interesting points. Take this MMV Power DVR. Now, this DVR was, I'll be honest with you, you can't even buy it now. It's a couple of years old now. It's been around for such a long time, but it is really poor. And to be honest, it's one of the worst devices we've actually looked at a basic level. Anybody can hack this device. There's around about 32,000 of them on Showdown, so you can find them really, really easily. Find them on Showdown. But the problem is that when you authenticate to it, it's got a web interface. Most DVRs have got web interfaces that you connect to. The problem with this device is you don't actually need to provide any authentication credentials. You just need to have 2 cookies. DVR user, DVR password. Doesn't matter what the value is. As long as you've got those cookies, you authenticate to that device. Which is like, what? What the hell? And these things are on the internet, the public internet. Anybody can connect to these devices just by having 2 actual cookies. But we haven't reached the bottom with this device. We're a long way from reaching the bottom with this device. This device is so bad. The web interface runs as root, as most DVRs do. Most IoT devices in general run as root. But this particular device, the web interface runs as root. But to make it that little bit worse, what they've decided to do is allow the shell command from the web interface. So you can just run a shell from the web interface. By default, this is built into their firmware. And of course, these are on the internet. You just need those 2 cookies and you've got yourself shell access to this device, which is also conveniently sat on the inside of the firewall through port forwarding, for example. So you've now got a network implant just by providing 2 cookies. It's ridiculous, absolutely ridiculous. But again, we have not reached the bottom with this device. There is a little bit worse than that. This device is so bad that the developer of it actually coded in their own email address. And so every 30 seconds or so, it sends a picture of the CCTV camera images to their email address. So it's completely voyeuristic. So whatever the CCTV is seeing, the developers are seeing as well. I think their email address kind of got destroyed in the end because there was so much being sent to them. And we decided we'd just send them button moon because it's frame by frame of the opening credits, which hopefully destroyed their email account. And I think in the end now they have actually kind of closed it down. But it's just ridiculous. It's just ridiculous. How is that possible in this day and age that a developer can do that? But anyway, I said I'd talk about Mirai, so I kind of feel I ought to. So a little kind of a primer. Everyone knows about port forwarding, but I kind of want to explain it anyway. So obviously, when we look at a port forwarding device, let's imagine, this is our IoT device. We've got the firewall. We've got other devices on the network, and we've got a router. So as a normal user, you connect through the port forwarded port to the actual device on your internal network. Everything's great, right? As an attacker, I want to target that box. Of course, I can't target it because there's a firewall in the way. The great thing about port forwarding is that I can just target that IoT device through that very same port the legitimate user uses, and then if I can compromise that device, I can use that to compromise the other internal networks. And that's essentially what Mirai did. So Mirai obviously used port 22 and 23, so Telnet and SSH. Is that right? I think that's right. So those were port forwarded to the internet, bizarrely, for no reason I could understand, but they're primarily using UPnP, so that's automatically port forwarded to the internet. And so attackers were using those to then compromise them using default credentials. Now the problem with Mirai is that, as you're aware, there's very little that the end user could do to fix it. And let's be honest, they couldn't really be bothered to, because why? Their device still works. It does what they want it to do. So what if it's part of a botnet? They can still see their cameras, and they can still do what they want to do on it. It doesn't impact the device. But we kind of wanted to know what was going on. And so, as I say, we bought about 30 odd of these devices, and we had a little look around to them. And one thing that was really interesting is we noticed that a lot of them had a very similar user interface. This kind of user interface up here is all very similar, and this is kind of the web interface for it. And it was just kind of like, that's a bit odd, really. Why are they all very much the same? And these are all different brand names. A lot of them were kind of cheap Chinese brands. And it's pretty obvious, right? They are effectively being made from one standard image that they bought from a company. And after a lot of research, we found out that company's called Zhongmai. And Zhongmai have got a wiki page on their website. And what was really interesting is on that wiki page, it details a thing called a make pack. Now, a make pack seemed to be kind of a Windows-based system that you would use to customize the Linux installation that you would then apply to the device. And so essentially customers would buy this make pack and buy the install, create their install, and then put that firmware onto the device itself. And then, of course, the device, they would then ship it out. And that kind of, that makes sense now. We can kind of understand why they're all basically the same. But remember with Mirai, obviously there was huge amounts of press, and vendors, even the Chinese ones, they're not that stupid. They did kind of think we ought to do something here. So they kind of tried to fix it. And so what we're seeing now is vendors were using the make pack to fix it, to make the devices not vulnerable to Mirai. And the way they did that is by disabling Telnet and disabling SSH on them. That kind of makes sense, right? But the problem is, we can re-enable it, because they didn't kind of fix everything. And so what happens, when you port scan these devices for Telnet and SSH, you'll see obviously it's closed. But you also note, if you scan all ports, you'll note there's a port open called 9527. 9527 is a really cool port because it's used by the Sophia application. The Sophia application is, from what I can understand, is effectively the application that runs the web server and runs everything on the device. And so we can kind of connect to that. And I thought what I'd do is I'd kind of show you what that looks like. So I've got the device here. I just want to show you. This is my device over here. Unfortunately, I have to have it over here because there's no power over there. But this is my. I couldn't be bothered to bring the box with me because I don't want to. It's too much effort. So I just brought the board. So let's just quickly try and telnet to device. Now, it's not going to work because we know telnet's disabled on there, right? But we can connect to 9527. Now, interestingly, you don't really get any feedback, but bizarrely, if you hit enter on it, then asks you for a username. Now, what's really cool, because this Sophia application is running essentially the web application, it uses the same default username and password, which is admin and blank. So then you get this kind of weird sort of Sophia shell. But what's interesting is like, well, how do I access anything on here? Well, if you just type help, it tells you what you can do. What's that? All right, well, let's have a look at that. So that's really cool. So now we're in kind of a weird shell that has no feedback at all. But we know the shell is pretty much running as root because or we can assume it's running as root because most of these devices run as root. So let me just grab a command because I can't be bothered to type it. And it kind of does that not found stuff, which is a little bit weird. And sometimes it works, sometimes it doesn't. So let's have a look and see if it now successfully works. Boom, look at that. So now I've got root access to the, well, although it doesn't kind of look like root, it is, which is quite cool. So you can check the processes and you can, I think, cat the root password. So I don't even need to brute force the password. I've got root access on that device now. And what I've done is I've re-enabled Telnet. So effectively, this device is now vulnerable back again to Mirai, which is pretty cool, right? I think so. So Mirai kind of sucked, though, because obviously it only worked on Telnet. And now most network administrators with any kind of sense would kind of disable Telnet and SSH from the internet. It's pretty logical. Most people would do that. But these devices work primarily for people to be able to access them through a web interface, port 80. And most people will allow that through the internet. So we had a look at another DVR, which actually that one is the Florian DVR, but I kind of moved around a bit in the presentation. So we had a look at this Florian DVR, and what we found is through the web interface, we found a remote code execution vulnerability, which is really, really cool and really easy to exploit. So there's around 800,000 of these on the internet. Just quick showdown, so that's quite a large botnet if you can compromise it. And as I say, you port scan it and you see port 80's open, and obviously a real-time streaming protocol. That's for the video stuff, but we're not bothered about that. And we know the credentials are admin and blank. So default credentials, in theory, yes, we could gain access to it. But the reality is there's very little you can do. In fact, I'll show you the interface. So this is the interface. If you access it through Internet Explorer, it wants to install some crazy ActiveX, which allows you to do a lot more customization, but I don't. So obviously you can see there's very little. If I had a camera, it would display the cameras in here. So pretty basic interface. You can't really do a lot, and certainly you don't have admin access to the device. But, if I just quickly flick back to the present, actually, I'll just do it live. But if we, at the login prompt, provide a really long post request to it, and I'm going to be lazy and do it this way. And it'll do that the first time, which I don't really understand why, but apparently it does that. Is it going to work? What are we going to get? It's not working. Why is it not working? What's happened is we've crashed the web interface. Shortly it'll refuse to connect. So we crashed the web interface, right? So that's a buffer overflow, right? In essence, we've caused a buffer overflow. And so obviously, I mean, I'll be honest with you, I haven't written any proper code on it, but essentially what we've got is a buffer overflow or a remote code execution vulnerability on that device. If we started looking at the registers, this is actually some registers. Obviously, I use capital A's there, so anyone who does any little bit of exploit dev, which I don't before you ask, will understand that hex 41 is capital A. It's a great way to start kind of understanding where things are registered in the registers, and you can start to see that, and then you can start to build your attack. So ultimately, from this point, what we've got is we've got remote code execution on that device. Although, obviously, I haven't got a working exploit realistically here. Now, of course, a bit of time we could get that, but it does mean that we can kind of do anything from this position, which is pretty cool, right? So one of the things we could do is if we use these devices, we could re-enable Mirai, but actually we could do it in a much better way, a much more aggressive way. We could perhaps use Mirai to knock MalwareTech's kill switch for WannaCry offline. Because is that network really going to sustain 800,000 devices? Mirai had 300,000 and they knocked Facebook off the internet, so I'd like to see them try. I really don't think they'd have any success. And so you could re-enable WannaCry quite easily with a botnet of this scale. just through that attack, which is pretty cool. But obviously what I'm more concerned about is we can actually compromise internal networks. So I don't really care about DDoS. What I care about more about is protecting customers' networks. And so, you know, we could very easily, from that position, have a compromise with their internal network, and then, you know, ultimately we could start stealing their data. But remember, of course, these are on the public internet. This is port forwarded by default to the internet. So you can connect to any of these devices with this remote code execution vulnerability and compromise them, which is pretty cool. So I don't really think IoT can kind of get much worse, right? Except it kind of can. And that's where we kind of get into the realms of adult toys, which is obviously what everyone came for, right? No one wanted to see DVRs. You just wanted to see sex toys, isn't it? So let me just actually, I just quickly need to flick over to my Wi-Fi access point for that. Otherwise, the demo is going to fail. Yeah, see, look, it has crashed. I proved it. It did crash. Look at that. Cool. So I want to talk about this one. I haven't bought all of the sex toys we've looked at. We've kind of got a bit of a reputation now. We're looking at all of the sex toys. So Ken's walking around with a butt plug in his bag, which, yeah. I went through customs with this, and I have to say, when I was scanning my bag, I was just like, should I have put my bag in hold? I really don't want to have an awkward conversation with someone. Why have you got this weird endoscope dildo in your bag? And so, yeah, I mean, this is ridiculous. It is completely pointless. But, you know, what's really quite interesting is that there's a massive market in these types of devices. Teledildonics is actually a genuine term. And interestingly, not that I research Pornhub much, but interestingly, Pornhub are doing a lot of research into teledildonics. And you know, obviously male and female versions as well. And so, you know, it's becoming a massive business for the porn industry. And so, whilst, you know, it's kind of amusing that these devices exist, there is actually a very serious side to it that, you know, compromise of these devices can lead to some very serious implications. But back to this device. So this device, obviously, it's an endoscope kind of device, so it's got a little camera on the end of it, which I'll show you in a second. And it streams that camera image to a mobile app, so you know, people can see what's the dildo seeing at the end of it. But bizarrely, it acts as a Wi-Fi access point. So you connect to this Wi-Fi access point, and then you can view it. And so we had we thought, well, let's kind of try and understand a little bit about that, because obviously it connects to it. They tell you the password for the Wi-Fi access point, but they don't tell you anything more than that. You then, you know, the idea is you connect to it, and then you connect to use the mobile app. But we kind of wanted to know what was going on there. And so one of the first places we look when we're trying to understand what's going on is, of course, the mobile application. And I'm sure a lot of you reverse engineer mobile applications, especially Android applications, because they're trivially easy to do. The tool that I personally prefer to use, you know, once you grab the APK from the device, or from, you know, lazy like me, APK Pure, and then once you grab that APK, you can then really easily open it. And the tool I like to use is JDEX. It's just trivially easy. It just works. You don't need to do anything fancy with it. I mean, you can use Dex to jar if you want, but it's a lot more effort, I have to say. So let's just kind of have a look at the interface. Actually, I'll just check this is working first. Am I connected? Yeah, cool. All right, so let's have a look at the app. I'm sure you can all see that right now. Let me zoom in a bit. Right, so this is the app. Oh man, how do I get to the... There we go. So the first thing we notice when we look at the app is there's a couple of... I thought it was supposed to be on silent, for goodness sake. Oh well, I don't care. So the first thing we notice when we look at the app, though, is that there's some weird things down here. Sky Viper, winged cam. Doesn't kind of sound like a dildo, does it? That's a bit weird, right? What's really interesting is that this application, or this mobile app, is built using a load of drone software, which is nuts. Basically, this device is a drone. Which is a little bit weird, really. And so it's got all of the mobile app in there. And what's quite funny is we contacted the vendor after we found the vulnerabilities, and they were like, yeah, they just came completely blasé about it. They said, yeah, you know, the developer we used, they probably must have repurposed a load of their drone software. And so it was just like, what? And obviously we contacted this guy, Viper, and they were like, I have no idea what's going on, but yeah, whatever. Fair enough. The same developer must have used it. And it was just like nuts, absolutely nuts. But anyway, but because of that, there's loads of functionality in the mobile app that doesn't really need to be there. And also, we kind of find pointers in the mobile app to how we can authenticate to the actual system. And that's really easy. So it's in the main, what do they call them? I don't know what they call them. Anyway, the main section of the app. And what we can see is that we've got our IP address, we can work that out really easily. But the credentials for it, again, admin blank. Everyone uses admin blank, I have no idea. So to log on to the interface, we just need to use admin blank. So let's have a look at that. Let me get my web interface. All right. So I might have actually already logged into it. Let me close it and log out. Where's my mouse? There it is. I've already logged in. Anyway, you can get my point. But the bit that I want to show you, first and foremost, is that we can do a couple of things. Firstly, we can view the actual stream. And so that's quite cool. So you hit on that, and it actually shows you the camera. And so this is the actual camera. So what Ken and Andrew do is they put it in their mouth, which I don't like the idea of that, I have to say. I like to stick it in my hand because, you know, that looks better, doesn't it? And so yeah, I mean, in essence, it is an endoscope, so everything's like really zoomed in, understandably. You wouldn't want something zoomed out considering its use case. But yeah, you can, it's really cool on a keyboard, actually. You can really make out the dirt on your keyboard, which is obviously not ideal. And so first things first, you can kind of see someone's camera. So that's quite cool. So the default password for the SIMI is 88, should we say. So if you're ever in a hotel and you happen to see a Wi-Fi access point pop up called SIMI, just try to connect to it using 88. You might have an interesting video to watch, yeah. Maybe not. What else can we do from in here? You'll know, right up in the top left-hand corner, where's that nice one? You'll see something called device management. So let's click on that. Let me just zoom in on this so you can see it a bit better. So obviously, you can kind of see, this is kind of looking like a Wi-Fi access point, right? This is looking like your access point you would typically have at home. And so we've got loads of cool things we can do in here. Obviously, we can go into things like the basic settings and change names and things like that. Go into user settings and change the user ID for it if you want. Go to the wireless settings, which if you have got one of these, I probably would recommend you do that because obviously anyone can connect with the passcode, which I've told you about. And so, of course, you can do that, but then there's other cool things that you can do. If you go into like the record settings, you can enable recording. And interestingly, if we go into the advanced settings, you can even enable record settings and then send it, where is it? Oh, video settings. Is that right? I've got to find it now. I'm sure it's in the network settings. Oh, damn it. There's a setting somewhere, and I can't find it now. But essentially, you can enable the recording, and then you can enable it to record to your own NFS share. So you find someone in a hotel using one of these, you set your own NFS share up, and then you can start streaming it off to your own camera for computer for viewing later, if that's what you want to do. So there's loads of cool stuff, but you know, it's a web interface, right? And so many developers of these web interfaces, you see all of the time, how many routers do we see time and time again are being compromised because of really simple things, like a command injection. And so we spent a lot of time looking through this device and trying to find vulnerabilities in it that would ultimately allow us root access to the device. And through all of these. And so we thought, well, how can we get root access on this dildo? And we looked through all of the settings, and as I say, there's loads of settings in there. And yeah, it is there. Look, I was right. It was in the right place. And you can see we've got the network file share stuff, which is cool. I was talking about. But also, what we found is there's lots of other functionality. We can enable a device to start recording on a particular when it starts detecting motion, which is a bit weird. Remember, this is a drone. So think of it from a drone point of view. A drone camera has that functionality, right? And this is basically doing the same thing. And so what we can do with the device is we can start looking for command injection. But first things first, to kind of look for command injection, that's a lot of effort. Quite frankly, it would be a lot easier if we could just get the firmware, right? And what a lot of people do is they provide the firmware on their website. And so we tried to kind of identify who owns this particular device and whether we could get some firmware, because it's not, Simon are just the vendor of it. And the Mac effectively pointed back to Shenzhen Recam, which are a Chinese firm. And we searched on their site, and we found pretty much nothing on their site in terms of firmware. But we did find some documentation which kind of indicated that we could use this CGI command, and then we could enable Telnet, which is pretty cool, right? So we could then get Telnet on the device. So, we brought up Telnet, but the problem we've got is that we didn't know what the password was. And, it wasn't a simple password that we could just kind of guess. We tried brute forcing it. The reality is we didn't really get very far with a brute force. The password wasn't in our dictionary. So, and we couldn't find the firmware. So the only thing really for us to do is to peel back the foreskin, so to speak. And we took it apart. And so we took it all apart, and this is the various stages of taking apartness. And then we hooked it up to a number of devices, and we were able to pull the firmware from the device. It took about 30 minutes to extract that firmware. So, it's a sizable size, but what we couldn't find in that firmware is any kind of etc password to try and get the hash to then brute force that offline. So we plugged it into UART and started monitoring the device while we started moving around in the web interface, again going back to the kind of the command injection approach. And what we found, fortunately enough, is a lovely little command injection in the network share folder area. So found a nice little command injection, managed to get etc password off the device, which is cool. But then we tried brute forcing it, and it kind of, we didn't have any luck with that. So we couldn't crack the hash, which was frustrating, especially when you see the hash, the password. It was really, really poor. So I don't quite know what we've done there with our dictionaries. But what we knew, though, is we knew that the interface ran as root. We could easily find that out. So we found out that if the interface runs as root, why don't we just make our own user? And that's what we did. So we could use the interface to create, to turn on Telnet and create ourselves a new user, and then we can access the device as root. So I'm going to try and do that live with a nice little script I've got. So it takes a little while to do this, because for some reason the device takes ages to respond. And I can't remember whether or not I've rebooted it or not, so it might take even longer. Is it going to work? No, what an idiot. Schoolboy error. Okay, so I'm going to leave that running a little bit, because essentially what it'll do is it'll turn on Telnet using that CGI command, and then it takes ages and ages and ages waiting for Telnet to come up, and then essentially what will happen is it will drop into a root shell. But before we do that, let's just flick back to the presentation. So once we got root, we kind of realized that actually it would have been a lot easier if we'd have just looked through the firmware, because written in the firmware is the password for the root user. We just grepped for root, and there's the password. And you can see, how on earth, how did we not crack that? It's really poor. But anyway, we cracked it. But let's see if this is done now. Cool, look at that, done. So I've now got root access on that dildo. So it takes a little while, as I say, but of course we can see all of the PS commands, and then we can cat Have I made a spelling mistake? No, I haven't. Look at that. Cool. So we've now got root on the dildo, which obviously is completely pointless, but it's quite funny anyway. So yeah, I mean, our code is available for that if you want. It's on our GitHub page. So you too, if you find a dildo in a hotel you're staying at, you too can get root on their dildo, which will, I'm sure it'll please you, but it makes no difference to their life at all. So yeah, but you know, in terms of general advice, you know, there's lots of advice, and some of it's kind of sort of canned stuff. But you know, in essence, the IoT attack surface is huge. And if you are starting to kind of think about attacking IoT devices, don't just think just about the device itself. You need, and the server side of it, you need to kind of look at it all. And also, it's very important to try and pull that firmware from the device. You know, if we'd have really thought about it and hadn't kind of tried to go the long way round, we could have just grepped through the firmware and find the root password and instantly access the device. But certainly, in terms of IoT, the attack surface is huge. You know, you've got all of the mobile apps, you've got the API, the web apps, and all of the interfaces like Wi-Fi and Bluetooth, and the firmware, I/O ports, all of these different things. But IoT does have a really good opportunity for customer growth, and I think there's a lot of benefit to IoT. You know, I think some of us in this room have got Philips Hue, others have got other devices in their houses, and I bet we all really like them. They're really useful. They make our lives a little bit better. So, you know, I think IoT has got its place. But insecure IoT devices do have massive potential to damage the brand. You know, I can't remember what was your name? Edwin. Yeah, he was talking about the Cloud Pets attack. You know, IoT device made a huge difference. That device, that Cloud Pets device, you can still buy it, but it's such a ridiculously low price now that the company are not making any money. They're literally trying to throw it at people to get rid of it because the device is compromised. Kayla, you know, our doll that we talked about, you know, we totally and utterly owned that, and we're still talking about it now, which is ridiculous. That is in the Museum of Failure, which is we're quite pleased about. But not only that, it's a €25,000 fine in Germany for owning one, because it's an espionage device. And so, you know, there is a massive opportunity to damage your brand if you get it wrong. A couple of final thoughts. You know, OWASP have got some great advice, both from an attacking point of view, but also from a defending point of view, and the IoT Security Foundation. If you are looking to develop these devices, make sure the outsourced service provider, which undoubtedly you'll be using, specifies security in them. You know, I think it's obvious network separation, if you're implementing these devices, is fundamental, really. Any of our guys who've got any IoT devices, 9 times out of 10, they'll have it on a completely separate network, very limited with what it can do. Because the reality is these devices can and will get compromised. And test it, you know, get it tested. Either by yourself, if you're technically able to, or employ someone to do that. But certainly, you know, if you are looking to test it yourself, look at that firmware level, look at the application layer, look at the whole process and not just the actual device. It's not all kind of, you know, getting root on a dildo, so to speak. A couple of questions to ask. You know, look at pinning your SSL certificates. There is some challenges against that, but I think it's still got a very valid place, certainly on IoT devices. Look at what device data the device stores. A lot of these devices are now storing really, really personal data. Now, that's going to have an impact under GDPR and certainly under the Data Protection Act at the moment. And so bear that in mind if you're developing these devices. What do you need to store? And you know, lastly, make sure that you sign and validate your firmware. It's very important to do that, and it's not actually lastly. The last question is, you know, if someone stole one of these devices, what could your users be compromised with? And that's it. You know, my general advice, get a normal dildo. Any questions?
Do you think that the drones that were developed by the same guy could be susceptible to the same attack?
I would probably imagine, to be honest, that's a really good point. I've not really bothered buying a drone to test it, but yeah, I probably imagine that they are, because I imagine they're probably using the same firmware on the device, so yeah, that would make sense. Good point. Must buy one. Any other questions? Yeah. Out of curiosity, what CPU architecture do they use on dildos nowadays? Most of them are using ARM, I think. I'll be honest, I don't know off the top of my head, but most IoT uses ARM, and invariably Linux, the Linux which is running on it, is some kind of a cut-down version of BusyBox, invariably. Any other questions? Cool, thank you very much.